Generally in the past, if you guys did composite functions, you usually actually saw the function, but there's actually ways to evaluate composite functions without having what the function is. So one way is by a table, another way is by a graph. So this is kind of fun and kind of a different take on it, but the idea is the same. So this is going to really tell me if you kind of get the point of composite functions. So I want to take a look at the table. The top row here is your x values. The second row is f of x, and the third row is g of x. So we have x in the top, and then these two rows are generally what we would consider our y values. All right, so to do f of g of 1, all right, we're going to first evaluate g of 1. And once we get g of 1, then we can do f of whatever that answer is. Make sense? Okay, now this 1, what does that represent? Y or x? This is actually the x, okay? So what they're telling us with this notation, they're saying, hey, what is g when x is 1? So we come up, we find our x row, and we go over here to 1. But then we want to know what g is when x is 1, all right? Is that the middle row or the bottom row? G is the bottom row, right? So we go to the bottom row, and g of 1 equals 0, okay? Now we want to do f of g of 1, but now we know that g of 1 is 0, so we're really doing f of 0. Now 0, does that represent x or y? That's your x. So again, we're going to the top row here. We're finding 0, but this time we're evaluating f. So when x is 0, what is f? 2. Kind of fun, right? Okay, why don't you guys try to do the next 3? All right, let's take a look. Here, x is 2, so we come up to 2, and we're evaluating f. That's the middle row, so we get -2. We're trying to evaluate g of f of 2, so we're really doing g of -2. We come up here. X is -2. When x is -2, g is -3. F of 2, we already know f of 2. F of 2 is -2. And then f of -2, so we come up here. -2, f of -2 is 6. G of -1, so we find -1 for x. G is -2. And then f of -2 we already know is 6. Any questions about those?